Howdy, my name is Louis Schifino, and I will be discussing the power of two choices in randomized load balancing on behalf of Team 10, which is myself, Alex, and Aisha. So, before we discuss the power of two choices, it's important to understand a few concepts that are integral to understanding what it is. Starting with load balancing, which is a device that serves as essentially a coordinator for online traffic attempting to use a service. The load balancer uses various algorithms such as round robin or random assignment in an attempt to evenly distribute traffic among the various servers of an application. The idea with these algorithms is to choose something that's simple and requires little processing overhead, as this can lead to more expenses and potentially more wait time for users, but also something that will distribute the load as evenly as possible on servers, which tends to add complexity. Random selection is simple and efficient, but runs into trouble keeping the load evenly distributed among all servers. We'll talk about this more in a moment, but adding small considerations to a random assignment algorithm could result in an even distribution. Next is the supermarket model, which is used for modeling the behavior of a user attempting to access a web application, with choice-based server selection strategies while still adhering to random server selection. This means that the way the user is assigned to a server is still based in random assignment, but is given some choice based on certain criteria. In this case, the load of the server is considered. In the supermarket model, there are n number of servers and d number of randomly selected servers to choose, where d is less than or equal to n. Whichever d server has the least load is chosen for the user. The power of two choices can be boiled down to the idea that when d equals 2, in other words, when there are two choices, that there is an exponential increase in efficiency over d equals 1. There is continued improvement in choosing values for d that are greater than 2, but they only provide gradual improvements in efficiency that require more and more processing overhead. Put simply, d equals 2 is the most reward for the least drawbacks. Moving on to the mathematics and results used to prove the power of two choices. Kurt's theorem was heavily used to calculate the upper bound for average wait time for a user in the supermarket model, as well as determine the upper bound on the maximum load, or queue length. The results for the power of two choices demonstrate that, as I previously mentioned, that two choices is exponentially more efficient than one choice, and choices greater than 2 only have gradual increases in efficiency. The results also show that there's a low relative error between the simulated and predicted results, lending more credibility to the idea of the power of two choices. In summary, the power of two choices, that being when you have two choices for random server selection over just one, is exponentially more efficient. The supermarket model is used to demonstrate this efficiency and test its results, which show that two choices indeed is better than one in the situations crafted. Thank you for listening.